Assalamu alaikum, my dear fellows and student. Good morning. Today I am going to share my knowledge according to the fixed point theory, and here we shall discuss about the Chatterjee type contractions and geometric space, how we have to use this contraction like Banach contraction and Canaan type contraction in previous lessons which I have discussed. It is the definition of a geometric space along with the five properties you can see from the screen. Second one is the definition of Chatterjee type contractions. You can see from the screen its terms and condition. Here the constant C belongs to half interval 0 and 1. In theorem, we have to use the Chatterjee type contraction like Banach contraction principle and Canaan type contraction principle. In previous lesson, we have discussed like this how we have to use this contraction in generalized metric space. Let's see. It consists of the first 5 steps. The first step is the Picard iteration, as usually we have described in Canaan type contraction and Banach contraction principle previous lessons. Let's see from the screen like this we have described it. The second one is the second one step we shall have to use the contraction like Banach contraction and Canaan type contraction. Here we have to use Chatterjee type contraction like previous lessons. G of first we take its two element initial x1 and x2, and we use here the mapping of a Chatterjee type contraction, and here C is the constant which we have discussed above. Like this, first of all we have to write in a mapping form, then x t of y and y, and here y and t of x and t of x, and use its previous calculated described position of a sequence and put its values. Clear? The brown colored part of a sequence element of a sequence which becomes a 0, and here the red colors elements is defining the triangular equality which I have used in between 0 element and x2 element, and we get the like term to the g of x1 and x2. Here we get this element and we take it on left side and make a common c over 1 minus c and initial g of x0, x1 and s1. Similarly, we have to take its second and third element of the described sequence as above, g of t of x, t of y, t of x1 and t of x2 and t of x2 like previous, making a mapping form, and here we have used x t of y and t of y, and y t of x and t of x. That this element shows t of x, this element shows t of y and t of y, that is x, and here t of x, y and t of y. Here this use we have used like y, and this used t of x like this and t of x like this. That is, it means k x ty and ty plus y t of x and t of x like Chatterjee type contraction, and its calculation is so easy. Calculate it like this, you can see from screen. To stop the video you can see easily and calculate at your own page. In the same manner we can say that for an element g of xn, xn plus 1 and xn plus 1, make it mapping form and apply the Canaan type contraction, Chatterjee type contraction like Canaan and Banach contraction, or make its calculation like this. You can see from the screen, very explained manner. You can see it's a very easy process, and we get like this up to so on. And here we have used Canaan Chatterjee type contraction again and again. We get its nth form, or we get, so in After applying the Chatterjee type contraction again and again, we get its last step, c over 1 minus c whole raised to power n, and its initial element g of x, not x1 and x1, or we denote it beta raised to power n, where beta is equal to c over 1 minus c, which is strictly less than 1, and we can also exclude its value in which is equal to 1 over 2, which is less than 1 over 2, which belongs to 0 and 1 open interval. So our contraction is well and good for this theorem. Now here the third step, to make the iterative sequence to be a Cauchy sequence. Let's see from the screen. I have take m and n element, where m is greater than n element, and g of xn, xm and xm less than equal to, and in Cauchiness we have to you have to write the number of elements of the sequence in summation form, like this. We can see you can see from the screen like this, and put its previous values. We can find we have already find out b raised to power n g of x not x1, which is the value of this term, and the next term it is the value of this term and the last term. Clear? You can see from the screen it is a so easy calculation. You can also solve. If not, then ask me and comment positively. Here we get b raised to power n, which is a common element from the given constant elements raised to power n plus 1 and m minus 1, which is a geometric sequence, or like infinite geometric sequence. We can take s of infinity e raised to power 1. Here 1 is equal to a of its initial element a1 and 1 minus r, or its common ratio r is equal to beta. So like this, it's a very easy calculation. You can see from the screen, and you know, inshallah mashallah. The fourth one is the fixed point of a sequence which converts in a complete metric space. Now here we have to use g of x, tx, ty. Like this, we can in geometric we can write here x, tx and tx. Its color values shows the triangular inequality. Once again, it's a very easy calculation. Here it's operator form. We can write the above this step in operator form, and here after operator form we can use the contraction like this, that is x, ty and ty, and that is y, t of x and t of x. When n approaches to infinity, all this goes to 0. Its distance becomes 0, so t of x is equal to x. It means t has operator t has a fixed point in a space x. If a fifth one is the uniqueness. If we have a two element second element y not equal to x, when another element in a space x, show that t of y is equal to y, like t of x is equal to x, we can use also g of x y, we can write in geometric space, then in operator form as x is equal to t of x and y is equal to t of y, and again y is equal to t of y. Here we have also used c times by using the Cannon type Chatterjee type contraction x ty y and y t x x. So we get these values. It's a very easy calculation. Here we again we get this value which is like to this one, and we put it to the left side and gives us the common c over 1 minus c, and this is strictly less than it is a small distance which multiply to the given distance, which is also very small element, which this leads to contradiction. So it means that x is equal to y, t has a unique fixed point. Then comment positively.
Wave mile.